So this week, we're going to look at a human trait instead of continuing on with the pea plants. So we're going to look at a widow's peak in hair, when your hair kind of comes down into a V. And having a widow's peak is a dominant trait. So that means not having the widow's peak would be a recessive trait. Let's see some examples of what this would look like.
I do not have a widow's peak.
I do not have a widow's peak.
I have a widow's peak.
Not have a widow's peak.
I have a widow's peak.
No, I don't have a widow's peak.
I have a widow's peak.
Don't have a widow's peak.
I'm bald.
So remember, we're looking at this hairline gene, but then the two alleles or forms of a gene would be having a widow's peak or not having a widow's peak. So we'll use a capital W for the widow's peak gene since it's dominant, and then we'll use a lowercase w for not having the widow's peak because that is recessive. Now, everyone has two of those alleles since they get one copy from mom and one copy from dad. So if they have two dominant alleles, like this, it's called homozygous dominant. This prefix homo means same and dominant, so they're the same and they're both dominant. Now, if they have one dominant allele and one recessive allele, then it's called heterozygous because hetero means different. So, heterozygous, the two alleles are different. And then lastly, they could have two recessive alleles. That would make them homozygous recessive because the alleles are the same and they're both recessive. So these are the three possible genotypes. Genotypes being the combination of alleles that someone has for this trait. So those are the possible genotypes. Now a phenotype, on the other hand, that's the physical characteristic. So you can think phenotype and physical start with the same sound. Physical characteristic is the phenotype. And so in this case, the phenotype would be either having a widow's peak or not having a widow's peak. All right, so let's bring this together. We have three possible genotypes. One of them is homozygous dominant, which is two dominant alleles. So that's their genotype, their two alleles. The phenotype then, for that combination, would be they have a widow's peak, because phenotype is the physical characteristic that comes from that genotype. Okay, our next genotype is heterozygous, which is when they have one dominant and one recessive allele. But because there's this dominant allele, they would still have a widow's peak because that trait is dominant. And then the last genotype is homozygous recessive, two recessive alleles. And so in that case, then their phenotype would be no widow's peak because they don't have any of those dominant alleles there. So how would we be able to tell then if a child was going to have a widow's peak? Well, we would use something called a Punnett square. So this square is called a Punnett square. And, but first we need to know the genotypes of our parents. So this practice problem says cross a parent that is homozygous recessive with a parent that is heterozygous. So remember, homozygous means same, recessive means that they would both be lowercase. So we're crossing a parent with this genotype with one that is heterozygous. Hetero means different, so our second parent would have one dominant allele and one recessive allele. So then, when we're doing the Punnett square, we put each parent's alleles on one side. So, say this is the mom. She could give the kid a recessive allele, or she could give them a recessive allele. That's all she can give them is just recessive alleles. So you can think about that these are in the eggs, okay? And that is what she is passing down, okay? The father here could give the child a dominant allele in the sperm, or he could give the child a recessive allele in the sperm. So then what we do is we take these alleles here into the box that they're next to, or that they're in line with, I should say. Now, we always still start with the uppercase one. So this one is going to be heterozygous, because we bring this dominant allele down and then the recessive allele from here. This one is also going to be heterozygous. Bring the dominant allele down from here, the recessive allele from there. Here, we're going to get two recessive alleles, one from here, one from here. And then down here, we're also going to get two recessive alleles, one from here, one from here. So if we look at this then, 2 out of the 4 would be heterozygous. 2 out of 4 is homozygous recessive. So what that means is it's a 50-50 chance. 50% chance that the offspring would be heterozygous, 50% chance that they would be homozygous recessive. Now what that means in terms of their phenotype then, there's a 50% chance that the offspring would be would have a widow's peak. And there's a 50% chance that they would not have a widow's peak, or no widow's peak. Well, guys, that's all for this week. Tune in next week to find out more.